I hope you're all well. Today I thought it'd be interesting to make a Nano Swinsid. I'm going to follow a tutorial on the internet that I found by a guy called Tolaemon. He released these boards. I had them made by PCBWay, 10 for a fiver. So we're going to turn these from this into this. I will link his how-to in the description. Now, I'm not an expert on this sort of thing, so when I tackled this, some of the things I looked at in that how-to were kind of like, well, okay, I don't want to go spending 70 quid on a programmer. I don't understand lock bits, I don't understand fuse bits. It was all a bit confusing. So hopefully this video will help you be able to do it by following the ways that I made a mistake and I didn't make a mistake. I'm going to be using a simple USBASP, 3 quid. I think there's even an Atmega 4 or something on there. It's like ancient. Most people who've flown drones or messed around with Arduino will have these tools. I'll just put the board on a board holder. Next thing I'm going to do is get some Amtech NC559 super sticky flux and a cocktail stick, and just get a little bit on the end there. Goes on there like that, and that sticky flux also helps the chip stick. I'm using a very fine tip, spade tipped, well, it's not that fine but it's pretty fine solder tip. So these are the Atmega 88Ps. We have a dot here. I think that is pin 1 there, and it's pin 1 there. I'm just going to align these up. You have to get it lined up perfectly, otherwise you might as well not bother at all. And with this, it's very, very easy to get frustrated, because all you've got to do is touch it and the whole thing will move. Got one pin caught there. I'm not too worried about the fact that it's got a bridge on it, as long as it's holding everything level. I'll deal with that in a sec. Just got one bridge there, a tiny bit of wick, and just get it out of there. GTFO. GTFO. Okay, hopefully you can see that. It's zoomed full in, so it might be a little bit grainy, but I'm just going along each of these and just giving them a little wiggle. Make sure they're not loose, and none of them are. And I'm happy with that. I'll just make sure that none of them are bridged, which none of them are. But you can see that I cleaned it up with a bit of isoprop. So next, I think we'll do the resistors that go along the top here. There we are. I've pilfered those off of spare boards. There's 4 bits in. You see I've got that one there. Let's just revisit that. There we go. Revisit it again because it was off camera. There we go. There's that one. Let's see if we can massage it back into place without killing it. Nope, resistor's a little bit too big. Shouldn't really be a cheapskate. I think that'll do it though. The trick is to be brave. Okay, so the one item I wasn't able to pilfer from old boards was these 240k resistors. A bit of flux on these pads. I'll try and line it up the best I can. That's got it. There we go. Not the prettiest, but that is on. So I'm just going to pilfer some LEDs off of this old, it's an old video transmitter, a VTX. These are pretty delicate, so then we're going to see them out here. One. So a quick test of the LED. So to program them, USBASP, £3. It's on 5 volts. There's a jumper there for 5 volts, a jumper there for 3.3 volts. It's going to be 5 volts. Just going to take this header, solder these wires to it, and then plug it into that. And then the other ends of these wires are going to go to this this header here. I've literally just soldered those through, and then tracked them through to here. They're actually labelled. So you've got VCC there. They're the most important ones, VCC and ground. So make sure I've gone correct on this drawing, which is attached in the description. Okay, so this is where I've got the drivers from. Just install them. There's a package manager there, which will install those. So now's the scary bit. Now's the time to program it. Now I had not much luck last night with this. I'm going to show you how I solved it. I tried 2 programs. I tried Extreme Burner, which failed, and I tried Kazama or something, which wasn't very friendly and also failed. And I ended up locking myself out of one of these chips, which I'm going to have to reopen. This is a Windows 7 laptop. This program I did not have extreme problems with. This program is called ProgISP 1.72. Much friendlier, much nicer. So what I'm going to do is I'm going to click USBASP. Obviously I've got the drivers. This is Windows 7. It may work on Windows 10, I don't know. I'm going to open the file, which is the Swinsid file there. Open that, load it into the buffer. I'm going to select the chip, which is an Atmega 88p. That's loaded in, Atmega 88p. USBASP. First thing we'll do, we'll make sure we can get a signature off of it. So, Command, read signature. See, I read ID successfully, blah, 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 blah. That means it can talk to the chip. We've got the ability to talk to the chip. We've loaded the file into the buffer, so we're going to write the flash. Flash written successfully. We'll make sure it's written it. We will read the flash. Flash read successfully. Now this is the bit that is really going to screw it up if you don't get it right. These are the fuses, and what fuses do, they set things like whether it's got an internal crystal, talks to an external crystal, whether you can write to it on SPI, whether you can't, whether the reset can work, whether it can't. But all you need to know to do this, if you're copying the same how-to that I am, is that these values here, OXF9, OXDF, OXEO, or 0, they are hexadecimal notation for the fuse combinations that you want. This is what they're actually doing if you really want to get involved in it. And what you've got to remember with the fuses is 0 is programmed, i.e. you're turning that on, and 1 is off if you like. So you can either go through these, and as you change them you'll see that the values change. Look, 22, now it's gone back to 62. And there are, and I will link in the description, fuse calculators where you can type in all of the things you want, like you want it a certain flash memory size and everything, and it'll work it out for you. But for purposes of this exercise, let's just type in the fuse values that he's given us here. So the low is 0x, which we don't need that part, and then we've got E0. The high is 0x DF, so that hasn't changed, and the extended is 0x F9. So I'm just going to check those because I know what can go wrong if I don't. don't touch the lock bits. So now I'm going to write these fuses. I'm going to check them one more time. Go. It's written the fuse bits. I'm going to write the lock bits. Write the lock bits. Don't know if you need to do that. I haven't changed them anyway. Now let's just see if we can still read from the chip. Command read flash. Read from the chip. So that's okay. It looks like we have programmed our chip. Once again, that program is called ProgISP, and I would highly recommend you look into that. So that is basically our Nano Swinsid ready to go. We'll just plug it in. I'll leave the header on it for now. Okay, so there's the Nano Swinsid in situ. Turn it on. You get that bing. That gives me some confidence. It's going to be a quick blast on SID tester. It's not going to be any music. This is an 8580 mode. Okay, so hopefully you found that interesting. That was my take on how to follow Tolemon's excellent how-to, but using cheaper tools. ProgUSB, which is a program that actually works, and a cheap USB ASP programmer. Now what happens after this is how I unbricked one of these chips using a parallel programmer. This is a TL8662 Plus. And basically what happened is when I used Extreme Burner and the other one Kazama, I somehow ended up locking myself out of these chips by probably setting the lock bits or setting the fuses wrong. What I then did was, after I got back from the pub, I soldered the chip onto this, so I turned the pin out into what it would accept, and then blanked the chip using this and then reprogrammed it. So hold tight. If you want to watch that, just be aware I did it when I got back from the pub. Okay, so what is it? Is it a dead spider? Is it some nightmare? No. It's my attempt to recover the Atmega. I'm going to try and recover this chip. Okay, so I'm trying to get you in there. That is the best I can do through the scope. Hopefully this will work. What I'm going to do is solder each of those to pin headers and then plug them in to that. So there we go. Okay, so here's our nightmare adapter. So all it's doing is taking this little package here and transferring the pins here. There's no rhyme or reason to this. I'm not even going to put you on the thing, because every time I do it screws up. Highly surprising. Look at the adapter. But we have a read chip. So we got a read Atmega 88PA. Well, it's not the right pin out, but excuse the audio. I'm going to put the fuses back to what they should be. So here we are in the TL866i 2 programmer, and I have fiddled the fuse bit now that I can get into it to read exactly the same. So low EO, high DF, extended F9, and that's what they look like. I'm going to open the Lazy Jones fix. So, okay, what I'm going to now do is program it. Hopefully it'll work. Sometimes it's flaky. Oh my god, it's working, and it's worked. So our little how you going adapter has served its purpose. We've got the chip back.